Right, today we got trapezoids and kites. So here's a couple of vocab words here. Trapezoid, a quadrilateral with exactly one pair of the opposite sides being parallel. Okay, you got pieces of your trapezoid. You have the bases, and those are your parallel sides. You got the base angles, and those are the angles that are formed with one of the parallel sides, and then one of what we call the legs, or the non-parallel sides. So honestly, probably should talk about legs first. Legs, those are the two sides of the trapezoid that are non-parallel. And then you got a special case of a trapezoid. We call it an isosceles trapezoid. Just like an isosceles triangle, a trapezoid with congruent legs. Notice that's not the basis. It's congruent legs right there. If you had two lines that were parallel and the same length, the only way that would happen is if it was a parallelogram. So it would have to definitely be the legs that were the same length, and then you could get your two parallel sides. Something kind of like this right here. We have this thing, we've talked about the midsegment of a triangle. Midsegment of a triangle is connecting the midpoints. So the midsegment of a trapezoid is connecting the midpoints of the legs. So if I took these 2 points right here that kind of look like the midpoints, draw a line through that, that would be considered your midsegment right there. All right, and then the kite, here's where the great debate comes in. The kite is a quadrilateral with no parallel sides. And that's kind of how we define it. Your textbook here, this is a definition from the textbook from the Pearson. It says a kite is quadrilateral with two pairs of consecutive sides that are congruent, and then no opposite sides are congruent. So actually here, really this definition, we probably need to add two consecutive congruent sides. But where the big debate comes in is some people say, well, isn't then a rhombus technically a kite? So it depends on if you consider it a parallelogram or not. So a lot of people want to say a kite to, kind of break it up into a different category. People want to say a kite is something with no parallel side. So it just kind of depends on how you word it, what the textbook definition. I went and searched before I started making this video on Google on how some other textbooks define kites, and they say just two sets of consecutive congruent sides. So it just kind of depends on your definition. Honestly, like on a major test or anything, we're probably not going to ask you a question where it's like could be argued, I guess, depending on your definition. But for today, let's go ahead and assume we're going to assume the sides are not parallel. And just to kind of give you an idea what that looks like here, you want two sets of congruent sides, and they're kind of hard to sketch. Honestly, I'm gonna draw the diagonals. That'll kind of help me. So something kind of like this. Here's kind of what a kite would look like here. You would say that these two sides are congruent, and then these larger sides are congruent. So two consecutive congruent sides, or two pairs, I guess I should say. Let's add that in, two pair consecutive congruent sides. All right, so got a couple theorems here. Trapezoid is isosceles, or if a trapezoid is isosceles, then the base angles are going to be congruent. So that means like B and C are going to be congruent to one another, and then A and D are going to also be congruent to one another. And then remember, since it's a parallel, or you got two sets of sides that are parallel right there, consecutive interior angles will also be supplementary, because I don't think that shows up in our theorems. So that's a little extra tidbit there. Look here, trapezoid is isosceles if and only if its diagonals are congruent. So if you watched the lesson from yesterday, there is one of those sometimes, always, or never, dealing with the diagonals of quadrilateral being congruent. So most of the times we say it's a rectangle, but actually the isosceles trapezoid has that as well. So that's one of our theorems there. I guess we're going to say AC congruent to BD. Okay, so show that CDEF is a trapezoid. Alright, so they give us a little grid. So not only do we need to show that the sides are parallel, we also need to show that they're not congruent. So it's kind of like a double thing that you need to do here. So we can, first of all, to show sides are parallel, find the slopes. Nice and easy there. So I'm going to say that M of DE. I don't really have a good notation for that, so I just say the M for like slope. So the slope of DE looks like it's up 1 and then over 3. So that's 1/3. The slope of CF is up 2 and then over 6, which reduces to 1/3 as well. So that verifies that they are parallel. Then after that, we need to go and make sure that they're not congruent. So that would be your work for that. So we need to show that they're not the same length. If we can show that they're not the same length, then we can verify it's not actually a parallelogram. So I'm going to find the distance DE. And we're going to use the distance formula here. You can also use Pythagorean theorem or think in terms of Pythagorean theorem. So we're going to go difference of our x's, 4 minus 1. And then you're going to square that. And then we need to do the difference of the y values, so that'd be 4 minus 3 for your y values. Okay, 4 minus 1, that'll be 3, so we'll do 3 squared. 4 minus 3, that'll be 1, so that'll be 1 squared. So that'll get us square root of 10 for that distance. Alright, and you technically don't need, like some people ask, well, do I need to break down the square root of 10 and the square root of whatever the answer is? And all we're trying to do is verify that they're not the same numbers. So usually I don't do any simplest radical form. But, you know, you can, I guess, if you want. But we're just trying to show that they're different. So now I'm going to go and do, CF. Same thing. Difference of your x's, that's 6 minus 0. And squared. And then F, what do we got there? Is that 2 minus 0. And then squared. Alright, so that'll be something like 36. And, well, that'd be 6 squared, right? So then 36 and then 2 squared, that's going to be 4. So then you get square root of 40 right there. So that right there you can break down in the simplest radical form, but I definitely know square root of 40 is not the same as square root of 10. So now that we've shown that DE is not congruent to CF, but they're parallel, that means this has to be a trapezoid. So there you go. That's kind of what we need to see there for verification. So, okay, next one here, kitchen shelf fitting into a cupboard. In the corner of a kitchen is an isosceles trapezoid. Find your angles. Okay, so notice here you got 50 degrees there. If it's isosceles, that means it's opposite, or actually not even opposite. I guess I should say across right here. Those should be the same right there, so that'll be 50 degrees as well. And then don't forget, kind of mentioned this earlier, since M and N are touching two parallel sides right there, those angles are consecutive interior angles that happen to be supplementary. So we can go and just do 180 minus 50 to get that 130, and that would be the two angles for L and M, 130 degrees for both. So trapezoid is not too hard to find all your angles. Okay, here's another thing here. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. Now, if you want here, I want you to go ahead and scratch this out and write this word right here. It's just the average. That's all it is. So take the two, add them up, then divide them by 2. Okay, the mid-segment is the average of the two bases. So let's talk about what sides are parallel. MN is parallel to, I guess, RA, and then also, what is that, PT or TP? All right, and then if you want to go and find the lengths here, you're going to go 1/2 the sum of the bases, or like we said, that's the average. Okay, so we'll actually apply this here in this problem here. So they say find MN right there. So all you got to do is just average your two bases right here. So we'll go 1/2 and then 16 and plus 9, I guess. So that'll be 1/2 of 25. So you could write that as 25 over 2. I think that should be like 12.5. And then we'll put our units there, inches. Actually, I think, let's see. Let's add this at the bottom here. They don't have one that has algebraic terms, so I always have students kind of get confused when we see that. So I'm going to go ahead and make one up here. Hopefully this comes out kind of nice. I'm kind of doing this on the spot. Trying to make it look parallel. Alright, there you go. Let's say this side here is like 4x plus, I don't know, 10 or something like that. And then, let me see if I can come up with something here. We'll make this like x. Trying to make the numbers come out kind of good. Here, let's make it 2x. Make this like 7x. And then minus like 30 or something like that. Okay, just making up numbers there. So hopefully this kind of comes out clean and just doing this on the fly. But anyways, you'll see problems like this here where you have algebraic expressions and people kind of get confused. I'm like, okay, what do I do here with these problems? So we're still going to do the same thing. We're going to take the two bases and we got to average them out. So I'm going to go and do 2x minus 6 and then plus 4x plus 10. And then I got to take all of that and multiply it by 1/2 or average it. And then apparently that's going to give me 7x minus 30, if I can squeeze it in right there. So before I start messing with this 1/2, what I'm going to do is combine my like terms inside the parentheses. So I think that gets us 6x and then plus 4. And then you got something like that. Now from here, there's two different things you can do. Sometimes the numbers are not going to be nice if you try to distribute the 1/2. They will in this case. So if you want to get around distributing, you could also multiply by 2 over 1 to cancel that out. But then you have to go and multiply the whole entire right side by 2 as well. So that's one technique that you could do to get out of distributing the 1/2. Now it does work out to where it comes out clean, so I'm going to go ahead and do that. So you're going to have, what is that, 3x and then plus 2, and then equals 7x minus 30. And then you're going to move over the 3x, or subtract 3x from both sides. You get 4x. You're going to add the 30, and that's going to come out to 32. Oh, and look at that. It comes out perfect. So that'll be x, and then equals 8. Right there. All right, and that's how you would do a mid-segment problem like that. And actually most of the times they'll like let you know that it's the mid segment, so they'll maybe draw something like this so you know like these 2 points are the midpoints. So they'll probably have to say something like that, or they'll say, you know, like JK or something like that. It's the mid segment, so they'll need to say something like that. But then after that, take your two algebraic expressions, average them, and then you can work backwards from there. So just wanted to add that in there. Let's do this theorem here real quick. It's pretty easy. Quadrilateral is a kite, or if a quadrilateral is a kite, then its diagonals are perpendicular. And this is actually really similar to the rhombuses right here. So these diagonals going like that, those are going to be perpendicular. You're going to say CA is perpendicular to BD. That's really all you got to do there. So I think we might use that a couple times here. Here's a corollary to that. So if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, and it's only one pair. All right. So you got to draw it out almost. Let's see if I can do it kind of well. This is the best as I can draw it. Kites are kind of hard to draw. So we will say this BC is congruent BA, so I'll put B here, A, B, C, D. So I think this should work out. So now we're saying that these are going to be your two congruent sides. Then these angles that are opposite right there, A and C, are going to be congruent. And B and D are going to be not congruent based off of my figure. Now you can go and rotate all the letters around and then kind of swap that out right there. But since BC is congruent to BA, then these angles that are kind of like opposite of them, those are going to be your congruent angles. So the way I think about it, it's always in between the two non-congruent sides. Those would be your congruent angles. So we'll actually use that down here and to the right here. So here's a kite. They drew it out for us. They labeled which sides were congruent. So like I was saying, these two sides right here, or those two angles, I'm sorry, those should be your congruent angles. So angle R is congruent to angle T. Then we got to think back to the sum of the interior angles of a quadrilateral. So if you use that n minus 2 times 180, and that was a lesson a couple units back, or a couple of days back, I guess, that eventually gets you 360 degrees. Most of you guys know that quadrilaterals, all the angles add up to 360. So then we'll say 360, that needs to equal the sum of all of your angles. So we'll say 70 and plus 88 and then plus 2x. So that's something like 158 plus 2x equals 360, and then we'll subtract the 158. I think that gets us like 202. Yep. So that'll be 202 for the angles, or the two angles, and then divided by 2. And then you get x equals 101 right there. So 101 degrees for each one of those right there. That's pretty much it there. Is enough information given in the diagram to show that the quadrilateral is an isosceles trapezoid. So let's look here at your angles. So we know it's quadrilateral. We don't know anything about the angles. We can see that those two are congruent. So something already weird is kind of going on there. So this might be a special case. Not sure. But we know that they all need to add up to 360. So what I'm going to do is add up all those angles. I'm going to go 102 plus 102 and then plus 78. Or actually, I need to type it in right. And that'll get us 282. So we'll say x and then plus all the other angles. 282 apparently equals 360. And the last angle when you subtract should be 78 degrees. All right. And then since we have, these two angles, consecutive interior angles, since those are supplementary and these two angles right here are supplementary as well, this is definitely a trapezoid. And then since your base angles are actually the same, we can say it's an isosceles trapezoid after that. And you probably could have recognized that right away with the 102 and the 102, but we need to verify that last angle to fully prove that it's an isosceles trapezoid. Okay, got a couple more here. Another kite problem. In between your two non-congruent sides, those angles are the same. So this is kind of similar to the one we just did here. So we'll say 2x and then plus 101 plus 48 equals 360. And I think, what is that, 149. And we'll go 360 minus 149 and then divide that answer by 2. And you actually get 2x equals 211, but then you got to go back and divide that by 2, so that's 105 and then 0.5, I guess. And we'll just leave it like that for your two angles. Another trapezoid problem. Okay, so if you've got trapezoid, remember consecutive interior angles, those need to add up to 180. So angle 1 actually is going to be 101. That adds back up to 180. And then look here, it's isosceles. So if it's isosceles, the two base angles are the same. So you'll have 79 degrees up there by angle 2. So those are a little bit more of their simple ones. Let's see what we got here. A couple extra practice problems. Good. All right, so sometimes, always, never. So let's think about this. Exactly one pair of opposite angles of a trapezoid are parallel, and that's just what we defined a trapezoid as. We said only one, so this is going to be always, and that's just based off of the definition. That's the same definition we gave a trapezoid at the very beginning. Okay, exactly one pair of opposite sides of a trapezoid are congruent right there, and we got to think a little bit outside the box. A lot of us just want to think of like any type of trapezoid here, and based off of that trapezoid I have drawn, there's no congruent sides. But you can have what we call the isosceles trapezoid. So I would say sometimes for this one. All right. 11, here's where you kind of get into trouble with the kite definition. All sides of a kite are congruent. So if you consider a kite with no parallel sides, then this would be false here. If you consider a kite where it can have parallel sides, then we would say, well, then a rhombus is a kite. So once again, it goes back to your definition. Based off of our definition and assuming there are no parallel sides, we are going to say never in this case. Okay, the only time if you have all the sides congruent in a kite is if it's actually a rhombus. And based off of our definition, again, we're going to assume that to not be how we define a kite. Okay, this one's kind of easy. A rectangle is a kite. That would be never in this case because a rectangle has parallel sides. Also, a rectangle generally has your two sides that are not congruent and they're not adjacent to each other. They're not consecutive sides, right? Once again, if we define a kite and we say you can have parallel sides, you can actually make a rectangle that looks like a square, and then you could say sometimes. But based off our definition we use today, I'm going to say never in that case. Opposite angles of an isosceles trapezoid are supplementary. So let's think about this. Opposite angles are supplementary. So let's draw an isosceles trapezoid. So let's say that this is like 100 right here. And then we know that this side has to be 80 if it's a trapezoid. But if it's isosceles, remember that the base angles have to be the same. So those angles that are across from each other are going to be supplementary. So I will say always. There you go. Okay, a couple more problems here. Let's see what we got going on here. We got 4x for DE. And then EG. Oh, I labeled it wrong. Okay, 4x is the diagonal. And then EG, the other diagonal, is 2x plus 16. So those should be congruent. Set them equal. That's only if it's a trapezoid. They tell us it's an isosceles trapezoid, so we know the diagonals are congruent. So that's 2x equals 16. So then x equals 8. Let's see, make sure. Yeah, and that's all they're asking for after solve for x. All right, check it out here. You have a kite. You need to recognize right away with a kite, you have a right angle. All right, if this angle over here is 5x minus 1, then it's also this next angle here because you're going to have an angle bisector going on there. It looks like that, and it's going to be like that as well. And then, since you have a right triangle, we know that the two acute angles add up to 90, or you could say all of the angles. I know that kind of looks messy. All of the angles add up to 180, however you want to work it. But I'm going to just say the two acute angles, those need to be 90. So we'll say equals 90. Okay, we'll add 1, and then I guess what do we have there? Is that 13x equals 91. I'm going to assume that goes in, but I'm not sure. And yes, it does. X equals 7. That's it there. So the key thing with the kite, you got to remember right angle in the middle. Okay, let's see what we got going on here with this one. So consecutive interior angles need to be supplementary with a trapezoid. Oops. So we'll put plus 4x, and then that all adds up to 180. So that'd be 10x, and then plus 20, then equals 180. So that's 160, x is 16. Okay, now once we have that, we need to go back and find y, but we don't know what y is. But we do know that y, since it's isosceles, these two angles should be congruent. So I'm going to take my x equals 60, and I'm going to plug it right back in there. And I'm just going to type that into my calculator so I don't have to do any mental math there. That's 16 times 6, which actually gets us 96, and then add 20 to that, and that's 116. So that's just plugging it back in, and then these two angles up here at the top are going to be congruent. So It's 116 degrees there. Okay, for last one, once again, okay, go away. Anyways, you got a kite. So kite, the diagonals are perpendicular, so you got some right angles going on there. And what are we trying to find here? X. Yes, here. Yeah, they give us more than we need. I'm not sure why this 3x is right here, but I guess extraneous information trying to confuse y'all here. I have a right triangle here. So you know that the two acute angles of a right triangle, so the 2x and 10x minus 6, those need to add up to 90. Or you can say all of the angles in the right triangle add up to 180. But regardless, it's 12x, and then equals, I guess, 96. And then divide that out, and then that gets you 8. And then I think, yep, that is it there for today.